All right. First of all, before we can go on, any questions from me before we start jumping into should be trying to get those iClickers registered, as well as sign up for that Connect platform that has the Learn Smart assignments, the first two due before we meet in class on Monday. All right, so I won't see you again until then because we meet just Monday, Wednesday. So when we start class on Monday, that's the due date for those two Learn Smart. So make sure you get on, get registered. Should take 15, 20 minutes to get through those, and we'll be kind of ready to go for Monday's class. Okay. So we left off last class, I believe we made it this far, right? We made it to talking about percent frequencies. So this is the idea. We come up with these frequency distributions. And then once we have those frequencies determined to relative frequencies, we simply divide it by what? Total number of observations. And then I turn those relative frequencies to percentages, we simply multiply by 100. Okay. That's kind of where we left off. I said, we'll start the class with this. So we won't use iClickers until Monday, but if we were to use them today, this would be kind of a good sample question, right? We've talked through how to calculate these things. We've looked at a couple of basic examples. I might then show you this data set and look, here's the top 10 causes of death. I want you to come up with a percent frequency of deaths that come from malignant neoplasms, which my understanding is that's basically cancer, right? So if we're looking at this, right, the first thing we should do is what? Take the frequency of the category we're interested in, so about 4.4 million, divided by the total number of observations. Now, if I didn't give you that total, we think about how did we come up with these frequencies? There was this huge data set, and it basically had every single death in the United States, and then it had the cause. So it was like if by hand, we would go through this huge data set, count the number of deaths that the leading cause of death was heart disease, then write that frequency down. Then do that for the next type of death and the next type. Now, every single, I guess if we're using cause of death, we're talking about the leading cause. So every observation should only be counted one time. So when we get done going through every single type of cause of death, all these frequencies should add up to whatever the original number of deaths was in that huge data set that we're not actually seeing here, right? That we would have been counting from. Okay. So we've got about 4.4 divided by the total number of observations of 16.6 million. You know, you don't have to be great at math. You do some really gross rounding. 4 out of 16 million is about a fourth. So it should be about 25%, right? So before we even enter anything to a calculator, we should be thinking, okay, what are we trying to come up with? Oh yeah, it's the percent of overall deaths, which is about 16 million that come from this one category, which is responsible for about 4 million. So it should be around 45, should be around 25%, right? If I go ahead, if this is an IR question, I would show you these potential answers. Just through thinking it, before you even touch the calculator, B and C should make no sense at all, right? I mean, for 4 million out of 16 million, I mean, you don't have to be an expert in math to know that's not 0.2%, right? And so we could probably rule B and C out. From there, it's just a matter of actually doing the math, right? So we've got that up at the top there. And we could do that for every single category, right? So we could come up with a percent relative frequency for every single category. Now, I've got it up on the screen, but these should always add up to 100%. Just like the relative frequencies, we said they should always add up to what? Does anyone remember? 1, right? So 1 representing 100%, right? It's percent. Okay. So from here, I might walk over there real quick. What we could start doing is something like this. Right. So if we have the kind of percent frequency here on the y-axis, we can start going through the very first cause, so heart disease. And just writing down the different categories and have every single category. Right? We can then plot the percent frequency for each one of these using a bar, right? And kind of create a bar graph that will give us a nice visual of what the distribution looks like for this specific variable, right? Where like the majority of the cause of death are coming from. So the first one is what, 32. I'll do some rounding here, but about 32%. The next one's about what, 27%. And then so on and so forth, right? So that was going to be the process of which we create these bar graphs. We're just going to go through every possible response for that variable. In this case, every cause of death. And then as the y-axis, we could use the frequency of death. We could also use the percent frequencies. It doesn't matter. And I think I've got slides to show you this. Okay, so here, let's say we first take this data and we just use the frequencies on the y-axis. So over there, I did the percent frequencies. But instead of using the percentages, we could just use the number, right, the frequency. So if I do that, my bar chart, this vertical bar chart is going to end up looking something like this, right? And it's a nice quick visual where you can see like, okay, heart disease and cancer are killing by far and away the most people relative to the other causes, right? So if I'm trying to like figure out where I should put some money, I should, try to attack those two leading causes. Right? If I instead use the percent frequencies, what's going to happen to that graph? If you think about it, how do we go from frequencies to percent frequencies? We just divided every number by the total number of observations. So if you divide things by the same number, like ratio of them doesn't change. So for example, 2 is 1/2 of 4. Everyone agrees with that? If you divide them both by 2, 2 and 4 now become 1 and 2. And 1 is still 1/2 of 2. Right? So dividing by the same value doesn't change the relative size. Neither does multiplying by the same number, right? We multiplied them by 100 to get the percentages. Well, multiplying things by the same number has the same effect. It doesn't change the relative size. So if we were to graph these using the percent frequencies, we get the exact same graph. It's just our y-axis is different, right? It's got the percent frequency as opposed to just the raw frequency. But either way, it kind of gets that information about the distribution of the data out pretty nicely. Nice visual there. Okay. Any questions over anything there? Okay with that? Shouldn't be too bad. We can also do pie charts, right? You've probably seen these in like 8th grade science, right? So the larger the slice of the pie, the higher percent of the total that category has. So you can kind of see it's another nice visual. Whatever orange and blue are here, we should care about those the most, or at least that's what's killing the highest percent of people. I'm not going to waste too much time on these. I'll show you how we create them in Excel. If not today, for sure when we start class on Monday. I'm never going to make you do these by, get a protractor out and try to draw the 32 degrees or whatever. We're never going to do this stuff by hand, but I will show you how we can do it in Excel. So qualitative tables in Excel, can we do this? Of course we can, right? We have that data set of every single death and the cause of death associated with it. There's a way that we can create these in Excel. Now, we're not going to do anything with qualitative data in Excel for these relative frequency or relative frequency distributions, but I do want to show you how we do it for quantitative, right? And that's most often what we're going to be dealing with. It's a very similar procedure for qualitative. If we have a little bit extra time on Monday, I might bring in some another example, kind of show you what that looks like, but it's pretty similar. So what if we're dealing with discrete data? So let's say I was thinking about, I wanted to look at the distribution of how many kids are in a household, right? So maybe I've got all this data of all these different households, and I've got whether or not they have 0 kids, 1 kid, 2 kids, 3, 4, all the way up to whatever the largest family is. All I would do, it's the same exact thing I was doing with qualitative. Instead of these words, right, the cause of death, which was non-numerical, I'm just going to go through my data set, count the number of households that have 0 kids, write that frequency down, draw a bar graph up to that frequency. Not a bar graph, draw a bar on the graph up to that frequency. Then I look at how many households have 1 kid, count them all up in the data, write that frequency down, plot a bar up to that level. Count the number of households with 2, 3, so on and so forth. It's the same process though, right? I'm just calculating frequencies from this data by counting. And then once I have the frequencies, I graph it in the exact same way. So nothing really changes when we're trying to get a frequency distribution for qualitative data versus discrete. But what if I have continuous? Well, here we have a little bit more of an issue, right? And sorry, like I said, I have the recording going. Days like today when I'm doing work over here, you probably won't be able to hear it as easy. Like I said, it's not going to be a perfect, imitation of the in-class experience, but it's something for if you missed class or one of that. Also, I'm starting to lose my voice. I think on Monday with you guys, but I definitely didn't have a voice at all Monday night or most of yesterday. So I'm still kind of working up to be able to get my voice real loud. So if we have discrete data, nothing changes. But what about if we have continuous, right? Well, let's say I was going to do income. The first thing I would have to do is, okay, what's the first value I could see for income? $0. Go through this huge data set, count the number of people who made $0, write that frequency down. What's the next value I could see? Well, now it doesn't jump from 0 to 1 to 2. Well, now I would say, how many people make 1 cent? Count them up, write the frequency. How many people make 2 cents? I have to go through and do that all the way up to whatever Jeff Bezos is making, right? I am then going to have the most ridiculously wide distribution bar chart, and every single bar is going to be really close to 0, right? Because I'm looking at exact cents. So it doesn't make a whole lot of sense to approach continuous data the same way. So what we're going to do is we're going to create bins, right? So for my example, let's say I choose 0 to 10,000. For my first bin, 10 to 20,000 for my second, right? So what I will go through and do is these bins, or the book sometimes calls them classes. I'll typically always refer to them as bins when I talk. I'll look through this data set and count the number of people who make between $0 and $10,000. I'll then write that frequency down and then draw my bar up to that frequency. Then I'll go through, count the number of people who make between $10,000 and $20,000. Write that frequency down, draw a bar up to that level. Okay. Does that make any sense? So I chose an arbitrary bin length here. But what's one issue that I might run into? What if somebody made exactly $10,000? Which bin do I count them in? I don't know, right? 10,000 is in both. So I can't actually, I have to do a little bit more here, right? When I'm saying it in words, I'm saying 0 to 10,000 or 10,000 to 20. I was just doing that to kind of set us up. What we're going to have to make sure we do, and we'll call X, I guess we could write the word income in here. We're going to say, okay, if it's less than 10,000, right, in the first bin, then in the second bin, we can put the equality on the 10,000. That way, if someone made exactly $10,000, they get counted here, but not there, right? So we have to be a little bit careful with our equalities when we're setting up kind of the cutoffs for these bins. The equality should only be on one of these, because if it's on both, now if I make 10,000, I get counted twice. And we don't want that. Every observation should only be counted one time in one of these categories. So how did I choose this length of 10,000? Well, I kind of did it arbitrarily. And what we call these bar graphs when we create these bins, so we're trying to display continuous data distributions, we'll just call them, it's a bar chart, but we'll call it a histogram, right? It's the same thing we were doing before, it's just that instead of specific values, we now have these bins, ranges of values, okay? So typically we try to choose a number of bins or number of classes somewhere between 5 and 20. If I don't choose more than 5 or more, it's not that interesting, right? If I was doing the income one and I said, how many people make between 0 and 100,000, how many people make 100 above 100,000? It's not a very interesting graph. It doesn't tell me a lot about the data, right? I need to make it a little bit more, broken up. And if I go more than 20, I just get a really long graph, right? It's not as nice visually, not as appealing. Okay? So there's no hard and fast rule for any of the homeworks or whatever. You'll be told how many bins there are, but usually between 5 and 20. And kind of a good place to start, and we'll look at this in the Excel file today. Kind of the good place to start a bin length that will always work, right, is you take the maximum value of your variable, subtract your minimum value, and divide by the number of bins that you want to use. This will always give you bin lengths that work and include every single observation. It's not the most practical, okay? So we'll use this usually as a starting off point, right? We'll calculate the bin length using this formula, and then we'll kind of adjust it, because it could be in this case, maybe I use that formula and I come up with the optimal bin length should be $9,432.85. Well, if I'm putting my labels like this on the graph, and I've got this huge number out that it's not going to look as nice and clean as if I could use these 10,000, right? So I'm really close to 10,000 or 9,400, whatever I said. I'll just round up and I'll use 10,000 as my bin lengths. But this is a good, this kind of gives us a good place to start. Some other things we have to make sure we remember. I already mentioned this one. These classes or these bins must be mutually exclusive. This is the idea that observations are only counted in one of these bins. This is a quality issue that we have to be careful with. And we'll see an example of that in Excel in a second. They must also be exhaustive. All that means is that any observation will be counted in one of these categories. So it's not going to be that we get to the the end of our data set and there's an observation that didn't belong in any bin. Now the only we can run into some issues here. So let's say I was doing this with income and I just kept doing $10,000 jumps. And maybe I do that up to the last bin. Let's say I just say if income, that X variable is greater than 100,000, count it in this last category. Kind of create these catch-all categories. It's kind of similar to our other category when we're using qualitative data. We want to make sure we include every single observation. So we create these catch-all categories. With continuous data, that usually plays out by being one of these catch-all categories at the end. Or if we had something where most of the data is high, but there's some really, really small, maybe we have a catch-all category at the beginning. Right? So exhaustive. And then generally we want to try to keep them the same length with the exception of if we have these kind of categories at the end, like catching any of the extremely high income values. Any questions over anything I said here? We're going to try to put it into practice in Excel here in just a second. Yeah.
When making histograms, formatting them, like do you care about the bars touching each other? Like
I don't. Okay. So what I care about, so we'll talk a little bit more about this when I assign the first Excel assignment, which will probably be next Monday. I'll probably get it up there. What I care about is that you're able to work with the data and to produce this graph. I don't care how pretty it looks. I don't care if it has even have a title. I mean, if it's not for this class, obviously, like you want the graph to be as descriptive as possible. So adding titles and labels, and that's great. That's not. I'm not going to waste class time to show you how to do that stuff. You should have learned it in like probably that ISOM class. I've been told that maybe you didn't, but yeah.
What did you say? Exhaustive.
Just that every observation in the data set will be counted in a category. So this was the idea. Like, let's say I only did this, and let's say I was like real crazy and I did $10,000 jumps, and I went all the way here, 490K to 500K, but I stopped there. Right? Well, there could be people in my data set making ridiculous amounts of money every year, and they're now not going to be counted because my last bin didn't go high enough, right? But to go high enough, I would have had to include so many more bins to get up to whatever Jeff Bezos is making. So that's why the only real issue we ever run into with exhaustive is if you stop at a value that's below the maximum value in the data set, which you shouldn't do, but that's the only way that usually would happen. Does that answer?
Yeah, thank you.
Any other questions? All right. So with that, I have a sample question. We might come back to this. I'll show you in Excel. So let's do some quantitative tables in Excel, right? So on Canvas, in the Files tab, I created this folder called in-class data. So this is where I'll put things up that we're going to, Excel files that we're going to work with in class. I put enrollments blank and enrollments complete. So the complete one is eventually what we're going to hopefully have created in class. So I always put up the complete version so you can go back and look at it if you forgot to save it while you're working on it in class or anything like that. But we're going to start with this blank file. So I've got that blank file pulled open. And I believe the way it downloads, because I renamed this for another class, I think this was called sheet 3. So this entire file is what you would call like an Excel workbook. And then within the workbook, we have multiple worksheets down here, these little tabs. Right? So here's some data on every university in the US and their total number of undergraduates. Right? That's what this variable is here. I then pulled out just Indiana to make it a little bit more easy to deal with. And we're a university in Indiana, so it seemed kind of fitting. I then have some other things that I've put out here just so I don't have to, you don't have to watch me type things out. And I'll kind of mention what they are as I go along. Now, one thing I did forget to do, I'm just going to go ahead and delete all these zeros. because I'm going to reproduce those for you anyways. So if you want to delete those and if you're following along, I would suggest that. I'm going to make it a little bit bigger so we can see what I'm actually doing. Okay. So in Excel, I'm going to start out talking about it as though you've never seen this or heard of this program in your life. Okay. So we've got these worksheets. I'm going to go to the Indiana one. Right? Got my Indiana data. Excuse me. Anytime I'm looking at a cell, it has its own reference. So like this cell right here is C4. Right? This cell down here is D9. Right? So anytime I look at a cell, it has a reference. And I can use those references to take the value in that cell and put it somewhere else. So let's say I'm down here. Anytime I want Excel to do something for me, I put an equal sign. Right? So I can have it do math. So equals 10 divided by 25. I can actually have Excel do that work for me. Right? So equal sign, and then basically you can have it do whatever math you want it to do, right? By entering it in. You have it add numbers, subtract, and whatever. Okay. What I can also do is after that equal sign, tell Excel, look, I want you to put in this cell whatever value is up here in cell C2. Okay. So if I click on that cell after I put that equal sign, it automatically puts that cell reference in there for me. I didn't even have to type C2 and I just clicked on the cell. So I then hit enter, and sure enough, it displays that value that was up in cell C2 down here, wherever I put equals C2. And, you know, the nice thing is, like, let's say, it wouldn't make sense in the context of what we're doing here, but let's say I figure out this school was wrong and it actually only has 50,000. I hit enter, it automatically updates whatever cells was using that reference. I'm going to undo that and go back to the real number, but right, it's kind of nice. We'll see later on. It saves us a lot of time if we use cell references. Any questions on that? So the next thing that we're going to kind of exploit in this class is, let's say I want to copy this value down, right? So I'm going to so as soon as this becomes this like bolded black plus sign, if I left click and drag this down, that's just going to copy that cell down. Wait, why didn't it copy that same value? Well, if we go down here and look, well, this doesn't say C2 anymore. It says C7. That's because anytime I copy cell references, it updates them by however many rows I'm moving down and however many columns I'm moving across. So I went down however many rows here, it updated that 2, must have been 5 rows because it updated it to a 7. Okay. Now that can be helpful for us sometimes, but sometimes we just want that same value, right? We just want exactly 72. So what I can do is what we call freezing the cell reference. So when you freeze a cell reference, basically now when I copy it, it doesn't update. So how do I do that? I just put a $ in front of the row and a $ in front of the column label, right? Now, if I hit enter and I copy this down, I once again, just left click that corner and just drag it down, it copies it. Now it stays as C2. So that's helpful, right? Freezing the cell reference, sometimes we need to do it, sometimes we don't. We'll see some examples of both today. Excuse me. So I want to get rid of these and show you a nice little shortcut for, oh, maybe. Not great. I'm not the greatest on laptops. C2. All right, that was the original thing we had in there. If I want to freeze this, I can, and like this really, it's easy enough to type in $2. It's just if you have a lot of like cell references you want to freeze at the same time, I can highlight them. And then on a Mac, I'll hit Command T, I believe. And then for a non-Mac, it's F4, or sometimes you have an FN button on your computer. You'll have to hold FN and F4, and then it automatically puts those $ in there for you. Okay. Any questions on that? Once again, on a Mac, it should be Command T, I believe. Okay. So that's kind of a helpful shortcut. So I'll get rid of these here. I was just kind of showing you some general Excel stuff before we start. So what I'm going to want to do, I have all these Indiana universities and their undergraduate enrollment. I want to create a frequency distribution for this. Okay. So what I'm first going to do is I need to use that bin length formula. right? So it was the maximum minus the minimum divided by the number of bins, okay? I've chosen the number of bins to be 6, easy enough. How can I find the minimum and maximum? Well, I could cheat because I downloaded this data already sorted, so I can see that the highest value is up here and the lowest value is down here. But if I had a much larger data set that wasn't sorted, well, I guess this one is sorted, but I'd still have to like do a bunch of scrolling, right? Or if I knew some other shortcuts, I'd still have to go down and find it. And maybe I want to add data to it in the future. And so then, well, now I've got to go back and do it again. I could just simply use a built-in formula that Excel has, right? So once again, I want Excel to do something for me. I put equal sign and say, I want you to find me the minimum, right? So MIN, it's a built-in function in Excel. I then put a parenthesis. So anytime I use a built-in function in Excel, I have to, call the function. The function here is min, and then parenthesis, it's going to need to know a few things, right? So here it just needs to know the numbers that you want to find the minimum of. Now you could type the numbers in here, or you could just select the numbers that you want to find the minimum of, which is this variable right here, right? The total undergraduates. So I can select, just with my mouse, click on and select all those values, excuse me, hit enter. It returns to me the minimum value, okay? Now what I could have also done was that equals min, put that first parenthesis, and then if I select the first cell in the data set, right, that first number, and then I hold all at the same time, so don't take your fingers off, Control, Shift, and then hit the down arrow. It goes all the way to the very bottom of the data set for me. So instead of dragging it down with my mouse, which like on a laptop is a pain, right? If I use that shortcut, Control, Shift, down arrow, and anytime I say something usually on a Mac, replace Control with Command and it probably works. So for a Mac, Command Shift and hit the down arrow, right? So notice it selected that entire range of data for me and it put those cell references in automatically, okay? So that's kind of a nice hint there, or a nice, I guess, shortcut. And then max, well, if min gives me the minimum equals max is going to return to me the maximum. Once again, click on that first observation, Control Shift, Command Shift on a Mac, hit the down arrow. I don't have to scroll up and close the parenthesis if I don't want to. I can actually just hit enter and it closed the parenthesis and kind of left the cell for me, okay? Any questions up to this point? Okay with everything so far? All right, so we now have everything we need to calculate that optimal bin length, right? Or at least the start, and I say optimal, it's the one that will always work, and it's at least a starting off point. So I'm going to take my maximum. So I just click on that cell where the max is in, puts that cell reference in, subtract the minimum, right? Click on the cell the minimum's in. And then here I've got something goofy going on my laptop. I have to change the settings after today. But I then want to divide by the number of bins, which is here in cell what? I3. So I'll put divided by I3. Right? I can't click on it because for whatever reason this is screwing with me, the size of this box. I have to go in and change the settings later. I don't know which one. Gonna have to spend some time troubleshooting it. So so I've got my formula, hit enter. Wait, how is my bin length like almost my maximum? What did I do wrong here? Yeah, right. So even in Excel, I still need to worry about the order of operations. So we'll be using a lot of parentheses to make sure we do that, right? We need to first take the difference between those two things and then divide it by the number of bins, right? So make sure that, we're still thinking about order of operations when we're doing things in Excel, okay? Now when we hit it, now I get something that looks a little more reasonable, okay? Any questions up to this point? And don't worry about this number yet. I'll get there eventually. I just didn't want to forget it, so I left it up there. So before class, before I posted this, let me keep it over here. I created these labels ahead of time just so that we have some labels for the graph and you don't have to sit here and watch me type them all in, right? So how did I know what the minimum and the maximum of each bin was going to be? That's what we're going to create now. Well, the very first bin, the minimum value should just be whatever the minimum value is in the data set, right? So I'll put, okay, it's the minimum value in that data set, right? The maximum of the bin should be, well, I know the bin length is 12,068, but I'm not starting at 0, I'm starting at 279, then the bin should end at 279 plus whatever that bin length is. Okay, so all I'm doing when I'm saying, I'll try to go a little bit slow, but when I'm saying like take that 279, I'm not typing that value in. I'm just clicking on that number, and it automatically puts a cell reference in there for me. And you'll see why in a second. It's going to make things a lot easier if I use these cell references. Okay. Sure enough, I get that the maximum of the bin matches up with that value I had ahead of time, but that is the correct value. Right? Well, then the next bin, just like we had over there, 0 to 10,000, 10 to 20, the next bin starts off wherever the last one ended, right? So this bin, its lowest value will be whatever the maximum of the previous bin was. Now, it won't technically be that, right? Because one of them has the equality and one of them doesn't, but we're still going to use that same cutoff value, right? It's by not using the equality on the one that we can get away with using the same value, because it's not going to be counted in that first bin, right? Because there's no equality on it. Does that make sense? Any questions on that? No? Okay. So my next bin starts off where the last one left off. And once again, well, where does the bin end? Well, I just take the starting of the bin and I add to it whatever this bin length I want to use is. And I keep doing this all the way down, right? So why not just copy these down, right? Yeah. So that was that formula. Yep. Hold on to that thought. I'll get there in a second though. Yeah, I used that formula that I had on the one slide to kind of come up with this. So it was the maximum minus the minimum divided by that number of bins 6. Okay. And I just use the cell references there instead of like typing in the values. That way, if I wanted to change it, like let's say I start going here, I'm like, you know what, actually, I want to do 8 bins. Well, now look, it automatically updates to give me the new optimal bin length. Maybe I want to do 12. Automatically tells me what the new bin length should be, right? So this is why using those cell references is so much better. If I just type the numbers in there, I got to click on the cell, delete the 6, put in the new number I want. Here I can just play around with kind of that bin category and just change it to whatever I want. We'll go back to 6. Right? So I could just copy these down, right? Because I want to keep doing the same thing. Each bin is going to start with the last one left off, and it's going to end, wherever it started plus the bin length. Right? So I'm going to copy these down. Okay, well, that's not good, right? So I click on here, what's going on? Well, wait, why is it adding I8? I want it to add the bin length. Well, I forgot when I copy these down, it updates every cell reference. So what I really want it to do, right, is I do want in the next bin, I don't want to keep using I8, I want to use I9, right? I'm starting off at I9, but I still want to add to it the value that's in the cell I4, right? That bin length. So I want I8, I want that cell reference to keep updating, but I don't want this cell reference to update. So I'm going to hold FN, F4, Command T on a Mac, put those $signs so that it freezes that cell reference when I copy it down. Now when I copy these down, notice, okay, yeah, I'm take the start of the bin, add to it the optimal bin length. Over in this column, it's always calling the kind of wherever the last bin left off, and that's where the next bin will start. I didn't have to enter this in a whole bunch of times, right? I just had to enter it in like for these first 2 and then copy it down, okay? Any questions over any of that? And you'll notice all these values line up with these labels I created ahead of time. So I went back in here, and before, there weren't any $signs here. So Command T on a Mac, FN F4 or F4 if you don't have an FN key on your laptop. Now this cell reference will not change when I copy this down. So I'll keep adding the bin length to get the maximum of each bin, but I'll allow the minimum of the bin to keep updating to the next one, which is what I want. So now if I select these 2, and actually I could have probably just deleted these. Now if I select these and just left click and copy them down, Now all my cell references are what I want them to be. Okay. Any other questions? Yeah.
So for the bin length, like what does the like 1/3 of a like a 0.33 like a 0.67?
Yeah, so it's kind of screwy, right? Because especially in this example, I'm kind of really cheating because this isn't truly continuous data because you can't have half a person. But it's the same idea and it's such a wide range of values that it approximates a continuous variable anyways. But you're right, you know, this is a little goofy. So that's why sometimes this is just a starting point, right? So I did something else over here, which I want to finish this example, but then we'll move here where I chose 7,500 because it's a little bit cleaner of a value. It makes a little more sense. But you're right. I mean, that's the problem, like strictly like I'm always going to use the value that this bin length formula gives me. Well, I mean, use a little bit of common sense. Like this is a very bizarre number to use as your cutoff, right? But I'm just showing you letter of the law how we would do it. Yep. Any other questions? We'll keep moving here. All right, so the next part's going to be, things haven't been tricky yet. This is going to get probably the trickiest part of what we're doing today. Okay. So I've got my cutoffs for each bin now, right? Now I want to count, right? This is the thing that usually you would have to do by hand. But what I can have Excel do is look through this variable, look through the data, and only count the observations that are greater than or equal to 279 and are less than 12,347.33. Right? And the way I can do that is through a function called countifs. Okay. So countifs is going to look through the data and count the observation only if certain things are true. So just like if you had any formula, so like let's say I was trying to predict y, and it was a function of x and z, right? I don't know. These are some x. I don't have to. Let's make this less complicated. Maybe something like this, right? So to come up with what y is, this function needs you to tell it the value of x and z, and then it can tell you what y is, right? Excel works the same way. When you tell it use the built-in formula countifs, it's like, okay, well, countifs has more than one thing you need to tell me. In fact, countifs here, we can have more, but for the sake of what we're going to use it, we're going to have to tell Excel 4 things. And we separate each one with a comma. So the very first thing, and it kind of prompts me down here, is what's the range that I'm looking through? What's the criteria range? Well, I've got my parentheses, so I'm going to go over here. I want to look through every single observation, all of the undergraduate values. So Control Shift, Command Shift on a Mac, hit the down arrow. Notice, if I can move this thing out of the way, it puts that cell reference where it says, look through cell C2 to C51. Okay, so that's the first thing that Excel needs, this criteria range. Comma, the second thing it needs is what's the first criteria? So our first criteria for this bin is the value of X, the undergraduate enrollment, greater than or equal to 279? So we could just try to put greater than or equal to, right? But that's not the syntax that Excel needs. So when we're looking at, when we're looking at operators here, like your equality operators, greater than, less than, greater than or equal to, we're going to put quotation marks around that, okay? And the way that we type it out is just like you say it. So if it's greater than or equal to, I put a greater than and then an equal to sign. If it's just greater than, I wouldn't have included the equal sign. Right? So now that it knows, like, okay, I've got the, equivalency operator correct, the next thing we're going to do is put an and sign. Now, if you don't use cell references, you can get countifs to work without this and sign, but it's just good practice that like sometimes use cell references, sometimes like values are, just get used to putting the and sign here and it will like never let you down, right? If you don't put the and sign, sometimes it'll work, sometimes it won't, depending on the situation. So I would just put the and sign here, get used to doing that because we're going to use this countifs formula down the road as well. So that's this, excuse me. So greater than or equal to, well, what value? Instead of typing 279 in, I'm just going to click on the cell that has it. You'll see why this is helpful in a second. Okay. So now here's my range of data. Here's my first criteria, comma. The next thing I need to tell it is, okay, go back through the data. Now that you've counted the observations that are greater than or equal to 279, go back through the data. So I have to select the data again. So I could do the same thing I did last time. Click on the first cell, Command Shift, hit the down arrow, and it would automatically put that in there for me. So I could do it like this, right? Or if I had a really big data set, so I only have like 50 observations here. What if I had like a couple thousand? Well, then I don't have to scroll all the way back up. It might be just as easy, since I already know where the range of data is here because I've selected it one time. I'm just going to type that in. So C2 through C51, right? So I can select the data again, or I can just type in those cell references. Okay. Comma, the last thing, the fourth thing we tell it is that second criteria. It went through the data, counted it. If it was greater than or equal to 279, it's going to go back through the data now, the data that was like left over that met that first criteria, and only count it if it's less than that 12,347. So how do we do that? Use our quotation marks, put a less than sign. We need to use that ampersand sign or the and sign, and then click on the cell that has the maximum of the bin, right? I can close the parenthesis there if I want it to really be complete. Any questions on that?
What was the last cell you clicked on, the J7?
So so the criteria, right? It's just like in that one, it's just a little bit easier to think about. The first one we had was 0 to 10,000.
Okay.
So the minimum of my bin I would count if it's greater than or equal to 0 or less than 10,000. That's basically what I did here with just two different values. Instead of 0 and 10,000, 279 and 12,347. But instead of typing the values in, I used cell references. I just clicked on the cell that those numbers were in. Does that make sense? And the reason why I did that is because I should only have to type this Countifs formula in one time. Right? I should only have to type it in one time, because if I copy this down, instead of using the minimum and the maximum of this bin, if I were, to go down here and start typing out that Countifs formula, well, now I want to use the minimum and the maximum of the second bin. Well, if I copy this down and I copy it down one row, these cell references, I7 and J7, become I8 and J8, or the two new minimum and maximum for the new bin, right? Now, so I do want those to update, but the problem is if I copy this down, right, just dragging, left clicking that corner, when it becomes that bold plus sign, dragging down should copy it. Well, I got an issue. Notice, yeah, it updates the new minimum and the maximum of the bin correctly, but my data starts in cell C7 now. So I didn't want the range of data reference to change. So I'll delete this and I'll go back. I'm going to select that range of data, Command T, or hit the F4 key, and freeze where I reference the range of data, because I never want that to change as I copy it down. The data is not moving. The data is staying in the same place, right? Any questions on that? So now, if I copy this down, the range should stay the same, but it'll keep updating the minimum and the maximum of each bin. Looks like I'm getting the right numbers. Now, one issue I'm going to run into here is I'm looking at this last bin and I'm like, well, why isn't this observation being counted? Well, notice on my labels, what is on the maximum of this bin that's not on the other ones? On equality, right? Because I knew that last bin, to get that maximum value in my data set, I needed to include an equality on that as well. And I can do that because there's no next bin, right? There's no bin 7. Now, sure enough, I count the maximum value, okay? Now, this isn't a very interesting distribution, which sometimes this can happen if you use like that formulas calculated bin length, because ahead of time, like most of the schools are going to fall in these lower categories. So I'd rather have more categories towards the bottom than I would the top. Like there's no schools in between here. I had one extreme outlier, which is kind of cheating, which is Ivy Tech, right? Because it just groups them all together. But you know, this is by the letter of the law how we would produce a frequency distribution. So I've got my frequencies now. Okay. How do I graph them? So this is the easiest way. I'm going to select my labels, hold control, and I'm guessing on a Mac it means hold command, select my frequencies that go along with those labels, go up here to insert. Now, if you look over here, there's a statistics chart option. You don't want to choose that, okay? What you want to do is once you have the frequencies, it's simply just a column chart, right? A bar column chart. So I click this, hold out here so my labels look a little bit prettier, and I've got my frequency distribution graphed. So all I had to do that was select the labels, hold control, and select my frequencies, insert. I could even do a 3D column chart if I wanted to, right? And that's all I have to do to create my histogram. Okay. Now I show you this method because A, I want you to get used to using cell references in Excel, using that Countif formula because we're going to use it down the road, using the min, the max, using these different things in Excel because we, like I said, we're going to keep using it. So you have to get used to it. Also, it allows you to do some things to that are a little bit. It allows you to create some different bins, like I'm going to show you in this second example in a second, that it's more difficult to do with a built-in histogram tool. So what you can do, and if you do this on the first Excel assignment, it'll have written in there that you're not going to get points if this is all you do. I need to see you actually use this Countif formula and calculate the frequencies. So I need to see the frequencies calculated as well. What you can do though, is if you go to select the data, insert, and then you do that stats chart, it'll create a histogram for you. It just is always going to choose these goofy numbers. It's not going to be as easy to set up like catch-all categories on it. Anytime I've seen somebody use this in the past, even though I have this talk every semester not to use that, someone's always still going to do it. I've only ever seen one person do it correctly and actually earn the full points because it's hard to mess around with. And if I give you predetermined bin minimums and maximums, it's a lot harder to use that built-in tool. It doesn't allow you to do certain things with the equalities. And so it's better to get used to doing it this way. Also, it's teaching you some of the tools and using some of the tools that we're going to need moving forward. So this is how I want to see you do it. Calculate the frequencies using Countifs and then just graph that bar chart, which basically a histogram is just a bar chart with bin lengths instead of exact values. Did you have a question?
Yeah, so are you normally going to give us the label, like the intervals for the?
Yeah, so I think in the first, so I'll probably post it on Monday after we get done with class. Usually I would give you like a Word file and it would have labels that are even prettier than these. And you can just copy and paste them into Excel. Yep. In fact, going on a little bit of an aside here. So the recording will have me in the middle of this. Let's see if we got Excel one right now. It's going to be a little bit different than this one, but have something like this. And then you can just copy and paste those labels. Save you a little bit of time, right? Any other questions before we keep moving here? Yeah.
So for like the last bin, for some reason I'm not sure if I just typed it in.
Yep. So that's the one that I had to go back in. And I said, oh, the maximum has an equality on it as well when the other ones didn't. So I had to go to this last criteria and I had to add in an equal sign as well. Less than or equal to. Yep. And now you should get one. Yep. Anything else? Yeah.
I can't remember if you said this or not, but for the Excel projects.
Yeah.
Did you say that you're going to have like a sample one that you created?
Yeah. So basically, we've started working through the sample, right? We're not done yet, but eventually what we're going to get to it's not under here anymore. It's under my Google Drive. Here's kind of your template file. This enrollment's complete. It'll have a bunch more things that we're still going to work on today. It's got some graphs over here that I'll show you. It has another example right here of how you could come up with a frequency distribution. We won't do all of this in class, but we'll do a large majority of it. And then, like I said, that other example for the all, that'll be on there just as an additional thing to look at. And that'll be kind of like your template file. It's not going to be one-to-one with that first Excel assignment, but it's going to have everything you would need to like piece together how to complete. Right, like I might choose 8 bins, or it's going to be a different data set, and so. Any other questions? We keep moving. Getting a lot of Excel kind of early on here today. All right. So I'm going to basically do the exact same thing. And I was a little bit lazier with my labels here. So I could have done the real nice greater than or equal to thing here. But because it's undergraduates, I know I could, there's not half of a person, so I could use kind of the next value. So I'm going to use the minimum and the maximum of each bin. And instead, I'm going to use this 7,500. So I did kind of a similar thing, except for I started out at 0. I then added the bin length to the minimum of the bin to get the maximum. The next bin starts where the last one left off, and I copied it down just like I did for the other data set, or the other, bin length example. So nothing's new here from what we did over here. It's just that I'm using different bin lengths, only 7,500. Now, what this means is when I got to the 6th bin, I was only at 37,500. Well, if I keep that bin length still 7,500, I won't be up to the maximum value yet. So a little trick you can do when you have these catch-all categories, I know that the highest enrollment is what, 72,000 here. So what I'm going to do is I'm just going to choose an obnoxiously large value, right? Like whatever that I just put 1 and a bunch of zeros. It's essentially like trying to use infinity, right? That's going to be the cutoff for my last catch-all category. Okay. Now, the reason I do that is because then I can still just copy and paste one Countifs formula down. So we'll get one more try at this Countifs, coming up with these frequencies. So Countifs, the first thing I tell it, I go over here, select my range of data, Control Shift, Command Shift on a Mac, hit the down arrow. Now you can kind of see, even though it sends me down here, the formula bar shows me what's in that cell. So if I scroll back up, so I can show you guys, it puts C2 through C51. That's exactly what I want. Right? So then comma, what's the first criteria? Is it greater than or equal to 0? Right? So greater than or equal to, in quotation marks, and sign. And then instead of typing in 0, to get used to using cell references, let's just click on the 0. Right? Easy enough. Comma, go back through the data. Once again, I could select it, but since I can see it here, I'm just going to type in C2 colon C51, which means go from cell C2 all the way through cell C51. And then the final thing I tell it, so comma, is the second criteria. Is it less than 7,500? Right? So less than, and sign, and then click on that cell that has the 7,500. Okay. This is the exact same thing we did with the other one. We're just using different bin lengths. And I'm doing it so the graph you can kind of see looks a little bit prettier. And the distribution ends up being a little more interesting looking. So when I copy this down, what don't I want to update? Yeah, the range of data. Yep. So I don't want the range of data to change. So that cell reference should stay the same. So I'm going to put dollar signs around it, or the shortcut, Command T on a Mac, hit my F4 key. I got to make sure I freeze both of the references of the data. But I want these to update, right? I want these to use the next minimum and the next maximum for the next bin. So now when I copy this down, it should work perfectly, right? It'll use the new minimum and the maximum of the next bin, keeps on looking at the same range of data. And now I've got, fewer bins that have zeros. It's a little bit more interesting of a distribution, okay? Want to see that cell again? Any other questions on that? We're okay? Okay. So hopefully we're good up to that point. I'm going to show you a couple more things, and a lot of this is just checks, but it's also convenient to have this information. So I've got my frequencies. If I wanted the total number of observations, there's two ways I can do it. And if I do it both ways, I can make sure that I didn't screw up my Countifs formula. Right? So the first way would be to do what? If I've got my frequencies, to get my total number of observations, I should just add them all up, right? So there's a built-in formula in Excel, which is the sum function. So I put equals sum and then a parenthesis. I just left click and select the frequencies or the values I want to add up. So P7 through P12. Hit enter. There's 50, which makes sense. You know, going from cell 2 to 51, that should be 51 different that should be 50 different universities. Okay. But another good check is I can also count the number of observations with just the equals count formula. So if I use that count formula, it'll count the number of observations from the cells that I select. So all I'm going to do is select this, every single observation, right? So I'll select that range of values, and it's just going to go through and count the number of cells that have something in them, right? Which should be every single cell that I just selected. Sure enough, I get the total number of observations is 50. Now that might seem stupid here to check that. You can scroll through the data and you can kind of figure it out with the numbers. But what if I had like every university, right? I want to scroll all the way down. Well, a nice shortcut here, right? Equals count. I select the first one, Control Shift, hit the down arrow. And then instead of scrolling all the way back up top and closing the parenthesis, I can also just hit the enter button and it'll do it for me. Hit enter, and it counts the total number of observations up for me just like that, right? I mean, how much time does this save instead of doing this by hand, right? Okay. So I did that check, everything worked out, okay? Any questions over anything up to that point? We can do a little bit more work here before we get out of here today. Good? So what if I want to create relative frequencies? I've now got my frequencies. I have my total number of observations. What do I have to do? I was going to ask you, how do I calculate the relative frequency here?
Divide by 50.
Divide every frequency by the total number of observations, which is 50. So I want it to do some math for me. So put an equal sign, take this category or this bin's frequency, and then divide it by the total number of observations down here. It's as easy as just clicking on those numbers. I mean, to me, I probably be annoying about it, but to me, using Excel should be way easier than using a calculator in the sense that I don't even have to type the numbers in. I can avoid making really dumb mistakes like hitting an extra 7 or something by simply I'm just clicking on the numbers that I want, right? We're almost making it easy. Okay, so we've got my frequency divided by my total number of observations. I could type this in for every single bin, but what's one thing maybe I could do, kind of copying this down so that I can copy this down and get it to be right for everything. Yeah.
Freeze the P13 and then drag down and copy.
Yeah, for the next bin, I don't want to use P7, right? In the next bin, I want to use P8. So I want that to change. But I always want to be dividing by 50, right? So I'll show you if I didn't, right? Got a bunch of errors, right? Because I screwed up. If I go up here and I want to freeze that cell reference that has the total number of observations, because I always want to divide by the total number of observations to get my relative frequencies. So I'll freeze that. Now when I copy this down, perfect. Any questions over any of that? If I were to use that sum function and add up these relative frequencies, what value should I get? So let's see if I didn't screw up. There we go. If you add them up at this point, you get anything other than 1, you're missing something, right? Something's a little bit off, okay? What if I, did not mean to do that. What if I want to do my percent relative frequency? Just multiply by 100. Take this, multiply it by 100. Easy as that. When I copy this down, Q7 becomes Q8, so on and so forth. If I want to do a check here, if I add these up, these percent frequencies, what should these add up to? Someone said it, 100. Sure enough. Okay. Okay with that for right now. I don't know how long that's going to take me. I think we'll save this cumulative frequency for Monday. So I'm going to jump a little bit away from this here in a second, but we'll come back to this idea of cumulative frequencies. I just want to make sure we get this idea locked in, so I don't want to like rush it towards the end if we run out of time. But another thing I want to show you, so I've got my labels, hold control. I could take my frequencies, once again, insert just a bar graph, and it looks something like this. All right. So I'm going to drag this down here. I could have also used the labels, use my percent frequencies, inserted this column chart. And this was the idea. If I put these side to side, I can, there. Right? These don't look, I can grab the right area. There we go. These don't look any different from each other, except for this y-axis. Here, I forget which one. I think this is probably the percentage one. And the other one is using just the frequency, just the raw number. Okay. Now, I don't have any labels on here. I could play around with this. So the easiest way, when you click on this chart, see how this plus sign comes up? I click on that. I can do things like add axes titles. I could add, doesn't really make sense. I could take my grid lines away. I can play around with the formatting just using that plus sign. Like I said, when it comes to the assignments, I'm not going to grade you on how pretty they look. Now, if you don't include like labels or something like that, I mean, that's different, right? I just mean in terms of like, I don't care what colors or if you're adding titles to it. But right, you should have some kind of, and it should automatically throw those in there for you. Now, one thing you might run into an issue with is, let's say I only select the frequencies and then I create my bar chart. Well, now I don't know what these categories represent, right? I mean, this isn't the number of ones, right? This is just the first bin, but Excel doesn't know what to call it. So anytime you want to change labels, so I'm going to click on these numbers, left click, see how it kind of puts a box around them. I'm then going to right click, right click, and see where it says select data. So go to select data, and here my axis labels are currently 1 through 5. I'm going to hit this edit button, and it allows me to now select, okay, what labels do you want to use? Well, I want to use these here. I just forgot to select them ahead of time. I was an idiot, right? So then I'll hit okay. Now it puts those in there as my labels, and my graph looks a little bit better. So even if you forgot to do it, you can add them in, and this will become important. I think I'll probably try to show you an example here today before we get out of here. When you're doing things like time series graphs, you're going to have to do that every single time. So the other thing that I want to talk about and show you in Excel, so we'll come back to cumulative frequencies next class, is this idea of scatter plots, right? So scatter plots are when we want to compare the relationship between two variables or compare two variables, right? So we're going to plot one of those variables on the x-axis, one of them on the y-axis. Then we're going to have every single data point on our graph. So for instance, I'll give you an example, and then we'll look at how we do it in a different data set in Excel. So here I've got a bunch of different countries, and I've got health expenditures per capita and life expectancy at birth. So I might be interested in the relationship between these two variables and think, okay, if a country spends more on its health, maybe its life expectancy also goes up, right? And if I can get a quick scatter plot that shows me that there's a positive relationship, that'd be kind of cool. So I go through and I take as my X value 3,452. I go over on my X axis to 3,452. I then go up to 81.5 on my Y axis and I draw a little dot. Then for the next observation, I go all the way out to 4,173, up to 80.5, draw a little dot. Keep doing this for every single observation that I have. Now I can do this by hand when I only have 20 observations. If I have a couple thousand or something, I can't do this by hand, right? So if we were to do this by hand, I actually think I did this in Excel too, but it would look something like this. And you can kind of see if I try to draw like a line that best fit this data, I don't know, maybe you could tell me there's a slight positive line, but these kind of outliers are throwing everything off. And that really maybe healthcare expenditures doesn't look like it's that related to life expectancy, right? They're increasing how much they're spending here, but life expectancies are kind of still all within the same area or same range. The only weird one is the US out here where we spend a ton of money and apparently get no return, right? Because our life expectancy is the second lowest. So, you know, this is a kind of a nice quick snapshot of the relationship between two variables, okay? So this is the one that I'm going to try to create for us. So we'll go back to that enrollments blank file, and sheet 3, if I right click on it, I can rename it. I'm going to name it vaccine percentage. So I don't know. What I find fun and interesting is sometimes incredibly sad, but I had an idea the other day of like, I feel like no one's, I don't know. I get angry when I read the news, but I was like, there's got to be data out there about states, the percent of people that are vaccinated, and whether or not there's any difference in new cases or deaths. And like, I feel like you never see these infographics or anything anywhere. So I went out and I grabbed the data and I figured I was going to prove it to myself. And I was like, well, I could use it for class too. So I two birds with one stone. So I've got every single state here, including like a few like the U.S. Virgin Islands, some other things, territories. And I've got the percent of those territories or states that are vaccinated. I have the number of new cases that they had in the past month. So I think I got this data about 2 weeks ago. So it's a little bit old, but, and then you've got things like number of new deaths, total deaths. So these are cumulative. So what we could do is maybe I just say, okay, look, our states that have a higher percent of vaccinated individuals, are they having fewer cases, like new cases, right? So all I have to do is select these two variables, and I could select them with my mouse, or I could use like that shift. So if I hold shift and hit the over arrow, it only goes over one column. If I then am just holding shift and go down, okay, I can go one at a time, or I can now hold control and shift at the same time and select the entire data set, right? So however you want to do that, you can just grab it with your mouse as well. You just select the two variables you want to put on the scatter plot. Okay. I'm then going to go to insert, go over to my charts here. You can kind of see there's one that looks like a scatter plot right here. Insert scatter. We'll just do the one that has like kind of the little guys here. And I can kind of see now the relationship between percent vaccinated and the number of new cases, right? So I don't know how big that is. We can kind of see we've got some weird outliers here. And looks like, honestly, once you get to like 60%, having a higher percent of your population vaccinated doesn't appear to really change the number of new cases you get. But if you look down here, right, increasing the percent you get vaccinated, if I try to draw a line of best fit, like through the lower part of this graph, looks like it's probably a slightly downward sloping line, right? As a higher percent of the population is vaccinated, tend to see on average that there's kind of fewer new cases, right? But that kind of relationship like appears to go away after you're like above 60%, right? So I don't know. This is not the end all be all, right? There's a much more, there's better statistics we could come up with, but this is an interesting first like quick snapshot look at it, right? If I click on these dots and then I right click and go to select data, just like I did before when I forgot to select the labels, I can also go, I should be able to, let me see. Why isn't it letting me select that? I probably didn't select the data points correctly. Come on. Click off of it. There we go. Oh, why won't it let me add that? It should.
I'm already forgetting how to do this. If I go to data labels. Now, select my data labels, select data. What? I'm gonna have to remember how I did this before. Well, we'll start off Monday with this as well, because I forget what option I did. It's not a big deal because I'm not going to expect you to do on the homework. But you can add in which states these are as well, like as the label. So you can see here, like Florida was the highest. I don't remember what it is, but since we have a little bit of time, I'm going to do one more. So to kind of show you an issue that can happen. So maybe I not just want to look at new cases, but I also want to look at the number of new deaths, right? So I click these two variables. They're not next to each other. So I can select this one, hold control, and then hold shift and then the down arrow. So I can select both of these, right? I selected two columns that aren't next to each other. Same kind of idea. I can put my scatter plot in and get this graph as well. It looks like a very similar thing. I mean, this is the number of new deaths. This was the, oh, did I delete it already? Well, we had it up here. This was the number of new cases. They look very, very similar, right? So it appears that, you know, the relationship between the percent vaccinated is very similar to new deaths and new cases. Like I said, it's just a quick first look and a snapshot at it. But that is how you would create a scatter plot. Right? So I think what we're going to do starting Monday is we're going to come back to that Indiana data. We're going to create and talk about cumulative frequencies. And I'm also going to show you some time series stuff. Once we do that, we'll kind of jump off into the next category, which we'll think about distributions and calculating means and variances and all these fun things. But that won't happen until Monday. Okay. So what should you have done before we start class Monday?
2 assignments.
Those 2 Learn Smart assignments, get on, get them read. I'll probably put up the first Connect and Excel assignment after class on Monday. So expect next week to have a little more homework to work on. Other than that, have a good weekend, have a good Friday. I'll see you on Monday.